All right, Mr. Claxon's digital electronics students. I wanted to come at you again here just to explain why I support that place value method, the place value method, instead of the successive division method for converting from decimal to binary. Why do I support that? One, because it works for both binary to decimal, or I'm sorry, decimal to binary, and binary to decimal. So it works for both conversion methods. You only need to have to remember one. And that's why I like it so much. For example, for 41 base 10, I would make my place values. I know that some of you may already have started to remember these, and that's awesome. If so, you know that this one's worth 1, this one's worth 2, 4, 8, 16, 32. Why wouldn't I need to go to the next one? The next one would be 64, and that's larger than 41. So I know I would need a 32 here. If I add 32 and 16 together, that's going to give me too much. 32 and 8, though, makes 40. So 32, 8, and then I'll just need the 1, and I can put some zeros in here. So 1, 0, 1, 0, 0, 1, base 2, and that makes 41. So, looking at this, how do you show work for these problems? I would like to show work for a tougher problem like 158 base 10. And 158 base 10, we'll have to make some smaller place values. Some people would rather make these as they go, and I understand why. So you got 1, 2, 4, 8, 16, 32, 64. And the reason why some people like to do this as they go is so they don't waste any, they don't make any that they don't need. Double 64, you get 128. I would not need to go to 256. So you'll start to remember your powers of 2 here. You really should start to memorize these. Doing this so much. So I need to make 158, and I have all these numbers to do it. So I would use definitely a 128. If I add that 64 to it, that's going to be way too much. If I add the 32, then that, let's see, 128. Oh, wait, that's going to be 160. Definitely not enough. So 128, and I've got the 16 here. That'd be 144. And then, so now I got 144. I need 14 more. So 14 more. This would make 12, 8 and 4 would make 12 and 14. And I could go back and check myself, maybe check yourself with the calculator. So, 128 plus 32, and there are different ways to add this. 32 and 8 makes 40. So that would be, oh yeah, I didn't add the 32. So yeah, okay, 16 and 8 makes 24. So I could say 128 and 24, that makes 152, 156, 158, whatever you need to do to double check yourself, okay? Now I'm just rambling, but I like to use that method of place value. One reason why is because when you get to binary to decimal conversion, that is, they call it the bit weighting factors. I just call it the place value method, because if you understand place value, bit weighting factors is, boy, it sounds fancy, and if that's what you want to roll with, then go with it. But you would use the same method right here. You would just make your place values, and then you assign weights to them. There's 5 place values there, and then 1, 0, 0, 1, 0. And so we've got 1 multiplied by 2, multiplied by 2, multiplied by 2, and multiplied by 2. And so now I just add the ones that have 1s in them, the places that have 1s in them. So 1, that would be 16 plus 2, and that is 18 base 10. So My name's Matt Claxon, and I support the bit weighting method. So given that, you should be able to show work for all the problems on your worksheet. Please show work for all the problems on your worksheet. Print that worksheet off if you need to. This is a pretty good summary if you wanted to print that one off just to look back at. Thank you for watching.